Hi, we're team number 3, and our team is conformed by Ricardo Rincon, Gonzalo Martinez, Rodrigo Calvi Zambrano, and me, Andrea Monserrat. And today we're going to present our final poster about the problem situation. And well, the purpose of this project and this problem situation was to find new energy alternatives to power vehicles in a more sustainable way. And for this, we made a research about the galvanic cells, fuel cells, and solar cells, which are one of the main cells used to for a sustainable purpose. So for the galvanic cells, we found that this consists on an electrochemical cell where spontaneous redox reactions take place to supply an electric current. And while this reaction, as I already mentioned, is a redox reaction, you can see it there in the poster, how it happens and what happens in there. And about the fuel cell, it consists in the production of electricity through the use of chemicals, usually hydrogen and oxygen, where hydrogen acts as a fuel element and the oxygen is obtained directly from the air. Other types of fuels containing hydrogen in their molecule can also be used, but they will not be as sustainable as pure hydrogen. And about the solar cells can be described as semiconductor electronic devices that, through the photovoltaic effect using sunlight, can convert solar UV energy into electrical energy. And to understand a little bit more about redox reactions, they involve electron transfers. And well, when the redox reaction happens is when one molecule loses electrons, then it is oxidized, and while another molecule gains electrons, then it is reduced.
Methodology. Throughout the course and following laboratory practices, our team would organize the observed results, notices, data, and measurements into an Excel spreadsheet, after which we'd create trend graphs with regression models fit for each type of result. For example, in the first 2 lab practices, we used linear and exponential models, and there was a practice in which we used the logarithmic regression model, and so forth. We based the regression models on the type of data results that we noticed. For the analysis of the electrochemical reactions involved in the startup of car batteries, in the lab practice, we built a galvanic cell made up of copper and zinc plates dissolved with solutions of zinc sulfate and copper sulfate. But we also included in the poster an example for lead acid galvanic cells, which tend to be the most common among car batteries. And also both the redox reactions that take place in both the cathode and the anode. And for the reactions, we also have included the reactions involved in the power supply commonly supply power to combustion engines for 2 types of hydrocarbon. In this case, piston engines. We have the combustion reaction for octane and the combustion reaction for dodecane, which is most commonly known as diesel.
Then we have the results and discussion section. We are mentioning all the environmental disadvantages and advantages of each of the 3 mentioned cells. So starting with the solar cells, one of the advantages is that they have an ideal cycle charge for car usage, and they do not require fuel or chemical reaction. The 2 disadvantages are the huge investments in the production and installation of these cells and the effect that the weather has on its efficiency. The galvanic cells can provide a steady amount of electricity for a long time. They are rechargeable and they are very lightweight, but they have a huge disadvantage is that they cannot be recycled and they exert leaks. At last, we have the fuel cells. These fuel cells can produce more energy with the same amount of fuel compared to any traditional combustion. And they don't produce any greenhouse emissions. But a great disadvantages is the poor research. This is, and the effect is the low performance of these cells. And at last, during this fuel processing stage, some gases are released by a fuel cell power plant. Then, in the modulation of the both reactions and the combustion engine, we made a model based on on a video that is right here. You can see the QR